Hello everybody, welcome to another math lesson with me, Cameron, because we all know the last one went magnificently. Yeah, so I'm sure you guys are all probably wondering something. Oh yeah, sum and difference of angle identities. Yeah, no one cares about this polar bear. Let's get rid of him. So, I'm sure you all are very curious to learn, what the heck is this? What is he talking about? Well, that's easy. I'm about to show you a boring example resembled by Arctic characters because winter's here. Now moving on, let me just walk over here and you guys are gonna follow me. Okay, you guys are like really rude. You're not gonna move? Fine. Fine, be like that. No, you know what? No, I'm dragging you. There we go, my hostages. Now, welcome to my stupid freaking monkeys. Welcome to my lesson in finding the exact value in an expression. Something very important you need to know for finding out the sum and difference of angle identities. Now, to start this off, we're going to be doing an example. Okay. Now, we're going to have to start off with a unit circle. Now, let's say that the number of degrees we're trying to find is negative 105 degrees. Now, to do this, we're going to have to map that out on the unit circle, and that will go into sector 3 here, and the line will go about here. So this is where we are. Now, there's still this opening area between the x-axis and 105 degrees. So what are we going to do about that? Whoa, would you imagine that? It's actually 75 degrees. Now, this is going to become extremely important, and we're going to come right back to that. So let me just move. So to sum things up with what we did with the unit circle, we started off with negative 105 degrees, which leads us to negative sine of 75 degrees. That is this area right here that we have in between 105 and the remaining x-axis. And then we can split that into two numbers that are already on the unit circle, which is negative sine of 45 degrees plus 30 degrees. Added up, that's 75. So it's relevant. Whoa! After that, we need to plug these into an equation called sine alpha plus beta. Here comes the mouthful. Sine alpha times cosine beta plus cosine alpha. Sine alpha times cosine beta plus cosine alpha times sine beta. And here's a monkey. Get out! So anyway, with the creepers out of the way, I can finally continue my lesson. Alright, so now we're left with negative sine of 45 degrees times cosine of 30 degrees plus cosine of 45 degrees times sine of 30 degrees. Yeah, that's fun. Now, an easier way to think of this would be, God, not you. Oh. Now think of this polar bear as the unit circle, and think of these penguins like the numbers in this big equation we had just made. Now, each one of these penguins represents one of the degrees in the alpha-beta equation. So what we're supposed to do is we're supposed to look through the unit circle and find the values of these degree symbols, basically, and pick them out into separate numbers. So separate the penguins from the unit circle, basically, and then we don't need that anymore. Now, moving on, we should have found the sines and cosines of these angle measurements, which will leave us with this. Negative square root of 2 over 2, that would be sine of 45 degrees, times negative square root of 3 over 2, which is the cosine of 30 degrees, plus square root of 2 over 2, which is cosine of 45 degrees, times 1/2, which is the sine of 30 degrees. And we're looking like that with all four of these penguins. Basically, you get the idea. There's four different numbers, there's four penguins, and yeah, you're supposed to combine them to get the final answer. So let me just boom, boom, boom. And with that, you finally get the answer of negative square root of 6 plus square root of 2 over 4. And penguin, no. Forget about that. No! Get out of... I hope that you all enjoyed this short little lesson about bad. I hope you all enjoyed this little lesson on the sum and differences of angle measurements. Now, this can tie into something else. Now, isn't that unbelievable? This is a secret. You can't tell anybody this. This is like the government is keeping it a cover-up. It is very important. All right? This ties into something. You ready? Solving trigonometric equations. I know, it's crazy. You cannot tell anybody. This is top secret. Oh, now you want to know how, Me telling you wasn't good enough. Fine, you know what? Fine, but you need to... You need to get in the bag. You're coming with me. There you go. There, now I can get some fresh air. Oh my god, stupid monkeys. And we're back. So you guys are probably wondering, how does the sum and difference of angle identities tie into solving trigonometric equations? Well, I got one right here. This is a trigonometric equation. Now, it may look complicated at first, but if you do some simplifying, let's think of all of the simplifications of this problem as a penguin. If you do some simplifying, you simplify this one, so you get rid of this penguin. You simplify this one, so you get rid of this penguin. Then you get rid of this penguin. And finally, you're left with this penguin. The final version of the problem. Now, this may not make sense at the moment, but look at it. That could be the sine or cosine of something on the unit circle. And what did we just learn? Angle identities. So if we look on the unit circle, we are able to identify the angle degrees of this number, so we can find all the different answers that would apply to this problem. And that is how it ties in. Now, this is top secret, so no witnesses. Is the coast clear yet? Sorry, this is top secret information. I gotta be sure I'm stealthy about sharing it with you. Alrighty. Now you know the secrets. Doesn't look like anybody's watching. Now you know top secret information about the sum and differences of angle identities and how it ties into solving trigonometric equations. You can't tell anybody, remember. Now, I hope that you all enjoyed this lesson, and I'll see you maybe in the next video if I do a video for my next project. Now, Mr. Fuse, remember, if you talk about completing the squares again, the ghost gonna get ya. Alright, I'ma kidnap you one more time. See you later.